In this video, I'm going to show how to build a custom tool that allows you to construct ellipses with the Geometer Sketchpad. To start, let's take a look at the completed tool. I'll come here to my custom tool icon, click on that, and I'll choose my tool, Ellipse by Foci and Point. I'll now move on to my sketch, and I'll click, and click one more time, and that gives me an ellipse. These 2 points are the foci of my ellipse, and this is a random point that sits on the ellipse itself, and I can drag any of these points. Before I show how I built this tool, I'd like to review a few properties about ellipses with you. So here I have another model of an ellipse where I've added a few more parts and labels. F sub 1 and F sub 2 are the foci of my ellipse. Point C is the center of the ellipse. And I also have constructed the major axis of the ellipse and the minor axis. Here I have a point P that sits on the ellipse itself, and I've connected that to the 2 foci to create 2 segments. I've measured the length of each segment, and I've added them together. And based on the geometric definition of an ellipse, that sum of those 2 segment lengths is always the same, a constant 11.92 in this case. Now, when I teach ellipses to students, I typically will have them start by building it with string or dental floss and a pencil that pulls the string or floss taut and then swings that around to trace out an ellipse. One nice benefit of doing this is then students can look to see how the sum of these 2 lengths, from P to the 2 foci, not only is constant, but that constant is equal to the length of the major axis. And students see that by dragging P to one endpoint of the major axis and looking at their string. The other piece of information which is helpful to know is that if you drag point P to an endpoint of the minor axis, each of these 2 segments is equal to half the length of the major axis. So you'll see in our construction to follow that if we're looking for the location of P and we don't know it, but we know the location of F1 and our major axis, we can construct a circle centered at F sub 1 whose radius is equal to half the length of the major axis. So that will come in handy soon. Before we build our custom tool that constructs ellipses, we also need to look at a rather clever way to build ellipses that was devised by a high school student, Danny Viscano. His method starts with these 2 perpendicular lines and continues by constructing 2 circles, each centered at the intersection of the lines. So here we have 2 concentric circles. Danny next constructed an array that started at the intersection of these lines and extended out to the larger circle, placing the point that controls the ray onto the circumference of that circle. So now notice we can drag this point and it spins around the outer circle. And let's give that point a name, point C. Danny next constructed a point where that ray intersects the smaller of the 2 circles, point D, and he constructed a line through point D parallel to this line. He then constructed a line point C perpendicular to this line that we just constructed. that gives us a right triangle, triangle CDE. Danny placed a trace on point E, and as he dragged point C, point E traced an ellipse. This makes for a very nice proof, by the way, if you'd like to undertake that. A nice thing about this construction is that the smaller circle, the diameter of it, is equal in length to the minor axis of the ellipse. And the diameter of the larger of the two circles is equal in length to the major axis, and actually is the major axis, and this is the minor axis. So by dragging the size of either circle and then erasing traces and dragging point C again, we can create a variety of ellipses based just on knowing the length of their major and minor axis. Now, another way we can make this construction even more robust is to first turn off tracing for point E, erasing the traces, and then using Sketchpad's locus technique. We want to create the locus of all points E as point C travels around its circle. So I'll select point C, I'll select point E, and I'll choose construct locus. And here is our ellipse. We don't need to trace it by dragging point C. It's simply here, and it's a very robust ellipse in that it changes its shape and size as I drag the points that define the size of my circles. So we're going to use this construction to build our custom ellipse tool. But we're going to do it a little bit backwards than we did here. Here we started by constructing the two circles, which meant that we knew what the length of the major axis was, we knew what the length of the minor axis was, and then we constructed our ellipse. But for our tool, we're not starting with the major or the minor axis lengths. We're starting with two foci and a point on the ellipse. So by starting with the two foci, we're going to see if we can, from that, figure out how we can construct the major axis of the ellipse, how we can construct the minor axis, and then once we've constructed the major and minor axis, we'll then come back and use this technique to actually build the ellipse. So it's working in a slightly different order, but Danny's method will be very valuable to us as we begin now. All right, now we're ready for the main event. We're going to build a custom tool that, given the two foci and a point on the ellipse, construct the ellipse itself. Where should we begin? Well, I am going to start by constructing a line through f sub 1 and f sub 2, and I know that my major axis lies along this line. I just don't know the endpoints of it. I am now going to construct a segment between my two foci and construct the midpoint of that segment, and that point, point C, is the center of my ellipse. If I select that point and the line and construct a perpendicular through that center, I know that my minor axis lies along this line. So let's do a little cleanup. I'll hide that segment and I will make this line solid. To continue, I will connect point P to my two foci. And let's measure the lengths of these two segments. I know if I add these two lengths together, that this length is equal to the length of the major axis. All right, so I am now going to take that length and divide it by 2. And I'm going to use this length to construct a circle with this as the radius, centered at point C. So I'll select the length and point C and choose construct, circle by center and radius. So here I have, let me just move all these over a little bit. Here I have my circle, and its radius is equal to the sum of these two lengths from P to the foci divided by 2, and that gives me the locations here and here of the endpoints of my major axis. Cool. Now, how can I find the endpoints of my minor axis? Well, as we saw before, if I construct a circle centered at f sub 1, again, with this as my radius, then these points here, these two intersection points of the circle with the line, those are the endpoints of my minor axis. All right, so now let's do some hiding. Our model is beginning to look a little crowded, so I'm going to hide these lengths. I think I can now hide these segments. I'm going to hide this circle, and I'm going to construct another circle here. And these 2 points, remember, are the endpoints of the minor axis. All right, so I started with just f sub 1, f sub 2, the foci, and this point P. And using them, I was able to construct 2 circles. The larger of the 2 circles here, its radius is equal to half the length of the major axis, and the smaller circle, its radius is equal to half the length of the minor axis. So now we're back into the territory of the Danny Viscaino sketch, where he started with 2 circles that controlled the lengths of the major and minor axes. So let's go ahead and build Danny's construction. I will use array starting at point C. I will construct a line parallel to this, to the major axis. Oops, not what I wanted. I wanted the perpendicular. And now I will construct the parallel. This gives us that right triangle that we built before. And if I select this point and this point, the one that actually constructs the ellipse, draws the ellipse, I can choose construct locus. And there's the ellipse. And wow, notice it passes through point P. So I have a lot of stuff I can hide now. In fact, everything here except point P, the foci, and the ellipse itself. All right, I can now select everything. Come here to Custom Tools and choose Create New Tool. I'll give it a name, Ellipse by Foci, and random point. And if I pick that tool, I click, click, and click, I can construct ellipses. Now, let's suppose we would like to show this tool to somebody else and walk through it step by step. You could, of course, show them this video, but here's a good technique to walk through tools that's especially good here for a complicated tool like this one. So we'll start with 3 points, the 2 foci and the point on the ellipse. And I'll tap again here, and with this tool selected, Ellipse by Foci and Random Point, I'll choose Show Script View. And this now shows me the entirety of my construction, all written out for me, step by step. So our givens are 3 points. So I'll tap on 1 point, the first focal point, the next point, the other focal point, f sub 2, and point P. Now that I have my givens selected, I can walk through my construction by tapping Next Step over and over again to see each step of the construction done and watch the results. So here we see the very construction that I just walked you through, all replayed. Now we're measuring lengths, dividing it by 2. We're constructing that circle that finds the endpoints of the major axis. Now we're finding the endpoints of the minor axis, and we're going ahead and constructing the ray and that right triangle. And now we're going to create the ellipse itself, and we're done. So certainly easier to watch my video to get a play-by-play of what those steps do, but this is also a really nice way to review for yourself what those steps were. So there you have it. A very interesting way of using the Geometer Sketchpad to create a custom tool that builds an ellipse given 2 foci and a point on the ellipse.